Lesson 4, applications of acceleration. And what we're going to do now is combine the 4 kinematics equations, our growing ability to do a little formula manipulation, and the concept of if I know 3, I can find 4, I can really find 5 things. We're going to be doing physics word problems. And don't panic. I think I told you last day, math word problems suck. They're terribly worded. They're often contrived. I would know how many tickets I sold because I'd be tracking the number of tickets. Why are you asking me to solve for that stupid variable? They're really contrived. Where in physics, I think they're much more interesting, and I'll try and give you, as this lesson progresses, some nice applications. So we're going to use our DFIC approach. I like example 1. I like example 1. Example 1 is a nice question. Here we go. Let's read the question. It says this: an object starts at rest. I would probably underline the phrase at rest. Travels 12 meters over the next 3 seconds while accelerating constantly. Find. Okay, cool. Front row Hannah, what does A want me to find? This is the nice thing. This is one of my arguments to say that physics word problems are easier than math word problems. It's usually pretty obvious what you're going to let the variable be, what they're asking you to find. Acceleration. So I'm going to be maximum organization for minimum amount of writing. Okay? I am going to do that. What did you say they're asking me to find, Hannah? I'm going to go A equals question mark. Have I written something down? Do I feel better? Am I more relaxed? Have odds of success gone way up? I'm big on that. You're going to find throughout the whole year, almost always, we'll try and write down. We can't quite call them a no-brainer because you got to know some physics, but we're going to try and say we can do this without even thinking about it. Okay. Now I'm going to read through the question looking for numbers and physics words. And the first physics phrase I see is at rest. Starts at rest. What does that tell me? What's 0? VI is 0. What if instead of saying starts at rest, what if it said came to a stop? VF would be 0. Those are 2 phrases you want to ding, 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 ding look for. What's that 12? Hannah, what are the units next to that 12? So what do I measure in meters? Time? Oh. And by the way, technically it's a displacement, but we're going to be kind of sloppy during this year, sadly. It's my fault. It's a displacement. It's 12 meters forward, but okay. Hannah, what's that 3? How do you know? Because they didn't say the word time anywhere. Hannah, do I know 3 things? Then I can find a 4th. I'm looking for an equation that has an A, a VI, a D, and a T in it. Which one? Hannah read to me D equals VIT plus a half AT squared. And she's correct, but she also wasted my time. Really? Are any of the values that we wrote down, Hannah, zeros? Which one? Can you see I could have written D equals a half AT squared? Or I could have written 0.5 AT squared, the version Sarah prefers, or AT squared over 2, the version I like, because to me that looks prettier, but whatever, for mathematically. Same equation. So start to keep your eyes out for zeros. They'll often give us a special subcase of the original equation. Hannah, what are we being asked to find? How would I get the A by itself? Which, first of all, do you want to use the left-hand equation or the right-hand equation? I don't care. You like the... What? Okay. What's the T squared doing to the A? What's the 2 doing to the A? Can you tell me my new equation? A equals... two D divided by, you said divided by A. I think we want to get the A by itself. So it's not going to be divided by A. It's going to be divided by T squared. that all right? So, I didn't leave enough room. Oh well, we'll try it. 2 times 12 divided by 3 squared. I can do that in my head. It's going to be 24 over 9 divided by 3 divided by 3. It's going to be 8 over 3. Is it 2.666666? So I'll go 2.67. Units, it's an acceleration. Meters per second squared. Good. Okay. B. Kai, what's B want me to find? VF. Okay. Look up. Don't write this down. I could use VF equals VI plus AT. And the reason I could use that is, what did I find in part A? The only reason I might hesitate is if I got part A wrong, what am I also guaranteeing? That I'm going to get? So if I'm a good test writer, I might try and avoid using an answer to find an answer, unless I have to, and there will be times when I have to use an answer to find an answer. I'll let you know. And your hint will usually be, oh, this question's worth 3 marks or 4 marks. That's probably a multi-step question, Mr. Dewick. So if I try avoiding using that one, if I use that and that, which equation? D equals bracket VI plus VF close bracket T over 2. We haven't used that one much. Okay. Kai, what am I trying to get by itself? Okay. Now, VI is 0, which means technically, everyone look up. I could do that, which makes this equation way easier because now the bracket doesn't make a difference. But I'll walk through it as though VF wasn't 0 because that's a much tougher equation to rewrite. I'll walk through it as though VI wasn't 0. Okay, where is the VF? Inside the? I'm going to deal with the brackets last. It's going to be reverse BADMAS. How will I move the T over? I heard someone say it over here. You okay with that? How will I move this 2 over? And I'm going to rewrite this. So now what I have is 2D over T equals VI plus VF. And I've taken care of that bracket now because now it's redundant. Now I don't need a bracket. How would you get the VF by itself? Minus the VI. So we'll get this. VF equals 2D over T minus the VI. Now in this case, the VI is 0. So now I'll cross it out just to say didn't need it. But had it been a number atom, I could still handle it. Kai, what's D? What's T? Oh, don't forget the 2, Mr. Dewick. 2 times 12 over 3. 24 divided by 3. Hey, you might even be able to do that in your head. 8. We must have started out, sorry, what are we finding VF? We ended up going 8 meters per second if we accelerate at 2.67 meters per second squared for 12 meters. Point being, Braden, here again, if I know 3 things, I can find the 4th, and I can pull it from the question relatively easily. Let's do another one. A dolphin accelerates from 1 meter per second to 7.6 meters per second in 5.5 seconds. Find A. Ooh, cool. Alicia, what are they asking me to find in part A? A equals question mark. What's that 1.0, Alicia? Well, it's meters per second, so it's got to be a velocity. Is that the initial or the final? How do you know? And it's tough for me to explain, except kind of look at the time flow of the question itself. I think it goes, the phrase from and to implies a past and a future. So I think I agree with you. VI is 1. I also, by the way, both in the last question and this question, as I was reading, skimmed the units. Are there any yucky units? Good. What's that 7.6? VF? What's that 5.5? Looking for an equation that has an A, a VI, a VF, and a T in it. There is one. Alicia, I want to try and rewrite this to get the A by itself. Normally I would say it drops down like a domino, but I'm going to move sideways to try and save paper because I ran out of room on the previous question. What's going to drop down like a domino? So I would write that first. Then what? What's the T doing to the A? So, remember that. What's the VI doing to the A? So, which one am I going to do first? And then all divided by T, and I'll put the A equals right there. Yep. Do you need to memorize this equation? Please don't. I'll teach you how to derive these. It just takes practice, but we'll get there. What was VF, Alicia? 7 point, and then minus 1 all over 5.5. This is a fraction. Is there more than one thing on the top? Probably going to need brackets around the top. I don't think you need brackets around the bottom. Actually, I might be able to do this in my head. 6.6 over 5.5 is going to be the same as 66 over 55 divided by 5. 6 over 5. Is it 1.2? I can do math in my head. Oh, let me, again, though, I would never do this on a test. I would type this into my calculator. I'm showing off right now because I have a big ego, but. Acceleration, units, Alicia. Yeah, final step, always put the units, and then if you want, you can put a box around the answer or something. Cool. Rachel, what does B want me to find? Okay. Oh, pause. Look up for a second. Remember for part B, back on example 1, I told you I could use VF equals VI plus AT, but that would be using my answer from part A. Suppose this was a test, and I finished early. I would actually quickly, to check my answer, I would go, oh, 0 plus 2.66. I would type a bunch of 6s in for the 6 repeating, times 12. And if I get the same answer as I got VF equals VI. Oh, why did I get 8 meters per second, Mr. Duke? What did I type in wrong here? Oh, T is 3, Mr. Duke. Geez, I typed in the distance. There's my big show off. If I get the same answer, the 8, both ways, I've probably done them both right. So that's something often on this unit, before I hand a quiz or a test in, that you'll often find you've got more than one way to solve the answer. If you got time, Hannah, do them both. And if you get the same answer both ways, that can't be a fluke. Got to be right. Sorry, Rachel, I think I was picking on you, yeah? What do you want me to find? Which equation? I think it's DI plus VF. You said minus. I think it's plus. Oh. Yeah, okay. Now, you might be tempted to go D equals VIT plus a half AT squared, because I know A now from part A. I would check my answer that way at the end really, really quickly. So I agree with you. I would use D equals bracket VI plus VF times T over 2. I need to get the D by its... Oh, hey, it already is! Plug and chug. VI is 1. VF is 7.6 times 5.5 all over 2. I'm definitely going to have a bracket around the top, and in the top, I'm also going to have a bracket. So I would go bracket, 1 plus 7.6, close off the mini bracket, times 5.5, close off the top, divided by 2. Do you have a calculator here, kiddo? Can you get out your smartphone, power it off, please? I'll swap you. Do you get 23.65? 23.7 if I go to 3 sig figs? 23 point, what was it, 23.7? Meters. Now, if this was a test question, I might really quickly try going VI 1 times T 5.5 plus 5.5, Mr. Dewick, plus a half times A 1.2 times T squared. And if I'm lucky, I'll also get the 23.7. The fact that I must have done part A right as well, because how could I have fluked into that? Okay. Example 3. I like example 3. I like example. I kind of like almost all of these. There's going to be one question that I'll tell you that I don't like, in that it's good, but I don't think it's fair game for a test. But number 3, sure. A car moving to the right at 30 meters per second, a car moving at 30 meters per second to the right slows down at 6.8 meters per second squared. How far does the car go before stopping? Ooh. Garrett, what's A asking me to find? Yep. By the way, technically displacement. In other words, we could get a negative answer if we were ending up behind from where we started from. So, okay. Garrett, what's that 30? Ooh, VI. So what's VF then? Oh, I probably should have underlined the little word stopping, or just made a mental note. Ding, 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 ding. What's that 6.8? Why have I just made a mistake? Can you see the mistake I've just made? It's very subtle, but this is wrong. What's negative? Are we speeding up or slowing down? Ooh, negative, because we're slowing down. Okay? Garrett, I'm looking for an equation that has a D, a VI, a VF, and an A in it. Which one? I don't know T. So I'm going to say nope. I need one that's got a D, a VI, a VF, and an A in it. Okay. Thank you. But we're working with Garrett, right? I'll come to you. Which one? Read it loud and proud. Don't write that down. Garrett, look at it on your green sheet. Is it on your green sheet? Okay, then writing it down on my white piece of paper is redundant because it's already on my green sheet. Stare at it. What are we trying to get by itself? What's going to, look at your green sheet, what's going to drop down like a domino? Let's do that. Write that down, everybody. Then what? Thank you. Then what? That equals D. If you can, by the end of today's lesson or homework, Mason, if you feel comfortable going straight to this without writing down the original equation because it's on your green sheet and I already wrote it down for you, please do. That's the point I'd like you to reach, where you can look at the equation on your green sheet, rewrite it in your head, and write our modified equation down. Okay? 0 squared minus 30 squared all over 2 times negative 6.8. Garrett, is this a fraction? Is there more than one thing on the top? Brackets around the top. Is there more than one thing on the bottom? Brackets around the bottom. Or use your fancy fraction button. 0 squared minus 30 squared divided by 2 times negative 6.8. You get 66.17, 66.2? Or am I wrong? No, I see people frowning. Am I right? Yeah. Units, Garrett. It's a distance, displacement. And the fact that we got a positive answer, we ended up in front of where we started. No dice, Hannah? So do you have the fraction button or not? Okay, so you should be able to double check for your squareds and double check for negatives. And if not, I can come look. We're doing some heavy duty calculator work. Don't kid yourself. You know what? I'm seeing enough people still typing. I'm going to pause. Logan, what's B want me to find? Yeah, and I think I already said the phrase in English, how long, is ambiguous. How long is the football field? Distance. How long is the movie? Time. But the fact that I just found the displacement, I don't think they're going to ask me to find the displacement again. So for B, T equals question mark. Logan, which equation? I don't want to use D because if I use one with D, that means if I got A wrong, I'm going to get B wrong. There's a better equation that doesn't need a D. So I got VI, I got VF, I got A, I'd like T. First one, yeah, VF equals VF. Don't write that down. Can you rewrite it and get the T by itself in your head, please, for me? I'll give you a hint. T equals. That's not a hint. Oh. Yeah. Yeah. Yes. Get a little nerdy adrenaline rush when you did that? Your little math nerd hardcore pitter pat? It's good. You're cutting down on your memorization. By the way, also what you're doing with rewriting these is you're starting to see how these fit together. We're going to often start to now look at, well, what if this gets bigger? What happens to our answer? Or what if this gets smaller? What happens to our answer? We can start to see how they fit together better. What was VF, Logan? Minus what was VI? Uh-oh, am I going to get a negative time? What was A? Ooh, A was negative 6.8. I'm not going to get a negative time. I'm going to get a negative divided by negative, which I'm pretty sure I'm positive. 0 minus 30 divided by negative 6.8. How long does it take this car to stop? 4.41 seconds. Is that okay, Hannah? Cool. Hannah, what's example, back row, middle row, Hannah, what's example 4 want me to find? By the way, you're going to start to notice I'm giving you less hints. So whoever I did the first one with, we read out the whole thing. Now I'm cutting corners and I'm just saying, read it yourself. What's it asking me to find? What is it asking me to find? I'm going to write down A equals question mark. What's that 15? It's got to be A velocity. VI. Oh, my units all match. I did a quick, I'm good with that. We're not doing any yucky conversions. And speeds up uniformly. What does that mean? It means acceleration is constant, so we don't need calculus. What's that 5? How do you know? What's that 85? technically a displacement, but yeah. Which equation? Equals VIT plus a half AT squared. Now, if you want to write that down, you can, but look at it at your green sheet. Look at it, look at it, look at it. See where the A is. See it? What side is it on? What's going to drop down like a domino? I think we can safely say the D drops down, yes? Okay, look at it again. What's right next to the A? And a 0.5, a 1/2. What are they doing? So eventually I'm going to divide by a 0.5 t squared. What else is on the same side as the A? There's something else there. Let's keep staring at the equation. You're good. So D equals, you've said VI each time. It's not a VI, it's a VI. It's another letter there. It's a VIT, is it not? Okay, I got to break you of saying it's not VI, it's VIT. So what else on the same side? VIT. What's the VIT doing to the A? So, talk me through it. The D drops down like a domino. Then we do our addition subtractions. So you told me subtract what? Yes. And then we do our multiplication or division. You told me divide by what? You should have a little nerdy adrenaline rush there. That's a pretty good one. Your little math nerd heart should go pitter-patter. That's a tough one. We can handle it with practice, but we can handle it. Is this a fraction? Is there more than one thing on the top? Probably brackets around the top and on the bottom. But here we go. Let's plug and chug. Let's see. It's going to be 85 minus 15 times 5 all over 0.55 squared. I might be able to do this in my head. 15 times 5 is 75. 85 minus 75 is 10. It's going to be 20 over 20. 0.8? Is it? Or am I wrong? Is it 0.8? 0.80, I think, like even? I'm seeing heads shaking. I might be wrong. 0.8? Oh, had me worried for a second there. Because I did it in my head, I'll add an extra sig figs just to show off. Hey, I'll add 2 sig figs, I'll go to 3 just to show off. Now, if you didn't get that, brackets around the top, divided by brackets around the bottom. Most common sloppy mistake, kids forget to put the squared on their calculator. They write it, but they're so relieved because they've done so much typing, they let their guard down 1 keystroke too soon. So check for squareds. It's an acceleration, Hannah. Units? Yep. Did you get that on your calculator okay, Hannah? I didn't need one, so there. Turn the page. I like example 5. Here's a nice application. I told you I'd try and give you some applications. So far, we've just been kind of playing around using the equations. So one area you can use this is an airport design. A jet airliner needs a takeoff velocity of 288 kilometers per... Nice try, Mr. Dewick. So, everybody right now, how would I convert 288 kilometers per hour to meters per second? I'm going to do this. I'm going to cross out the 288 kilometers per hour, and I'm going to write above it what I'm going to use. What is 288 divided by 3.6? 80 even? Okay. 80.0 meters per second. Ha, nice try, Dewick. So as I'm reading Donald, I'm also checking my units. Okay. In order to safely leave the ground, if the jet's engines can accelerate at 3.5 meters per second squared, what's the minimum length of the runway? Oh, cool. Huh. Donald, what's this question asking me to find when it says what's the minimum length of the runway? A displacement? Yeah. Okay. What's that 3.5, Donald, my friend? Gotta be meters per second squared. Even if they hadn't said the word accelerate, I could figure that out. Starting to see why I said it's worth memorizing what units go with what? Okay. What's that 80? I'll give you a hint. It's a velocity. Initial or final? Final. How many things do I know? I need 3 to find the 4th, so I guess I can't do this question. Or can I? What else do I know just because I've been on a jet at least once in my life, or I've seen them take off? Yeah? VI is 0. I've never seen a jet go careening around the corner onto the runway and just gun it without coming to a stop. So can we reasonably, I think, assume that? Okay. Donald, which equation? Can you read it to me? Stop. It is VF squared equals VI squared plus 2. Get the D by itself, please. I'll give you a hint. D equals. Yep. Yep. Awesome. Keep going. Yes. Keep going. Yep. Yes. Well done. If I can get you all to that spot, we're in good shape. And it's kind of nerdy. I mean, there is some nerdy coolness in being able to rewrite stuff like this. You know, full cred, right? What was V final? 80 squared minus V initial, 0 squared, all over 2 times 3.5. This one I'm not going to do in my head. I guess brackets around the top and brackets around the bottom, unless you have the fancy fraction button. These numbers are pretty accurate. I did some Googling and I looked at some jet airliners, and they typically need to be going about 300, 250, 80 meters per second to take off. It varies from model to model. Do you all get 914.3? 914? Now, this would be the minimum length. You'd probably triple this for safety. Because if you built the runway this long, that means you're backing up so that your tail is sticking out over the field and you're taking off right when your front wheels are just hitting the end of the pavement. You're not going to build an airport runway that way, but has to be at least that long, so you'd probably double it or triple it for redundancy. But 914 meters. Thank you for your patience. 2 more and we're done. Example 6, I don't like this question in that I don't like this question, I don't like this question, I don't like this question. I like this question because it's child playground slide application, okay? So it says this: a child slides down a playground slide, accelerating from rest. I would probably underline the phrase from rest, and traveling 6 meters in 4.8 seconds. When they hit the ground, their legs bend 20 centimeters. 20 what? Cross that out. What is 20 centimeters in meters? Now, some of you, if you need to do the full unit conversion, that's great, but I love the fact that some of you have used a meter stick enough that you know that 20 centimeters is 0.2 meters. So let's write really tiny underneath there, 0.2 meters. As the child stops, I would also underline the word stops, and the fact that I underlined from rest and stops, which are both 0, I think this question has multiple parts. Because if you're not moving at the beginning and you're not moving at the end, there's got to be something else going on here. A asks, how fast does the child hit the ground? And B asks, what's the child's acceleration in stopping? I think, Shay, this question has 2 parts. When you're on the slide and when you're on the ground. While you're sliding and while you're on the ground. And because it has two parts, there's my high-tech two parts. Shay, I said to you I'm going to be organized but lazy. On the left, I'm going to write, and on the right, I'm going to write. Although I'll be honest, if I wasn't teaching you, if I was doing this in my homework, I would probably just use a capital S and a capital G because I'm too lazy to write the rest of the letters, and I would figure out what I meant. What we're going to do now is we're going to read the whole question, and we're going to list data as to whether we think it's on the slide or once we're on the ground. Got the argument, Rachel? So a child slides down a playground slide accelerating from rest. That's a VI. Yeah, I think, oh yeah, you sit down at the top, you gather your nerve before you go down. Okay. Traveling 6 meters, is that 6 meters on the slide or is that 6 meters on the ground? .8 seconds, that's a time. On the slide or on the ground? Sorry? I think you're right, I just can't hear. Yes. And the fact that I've done this, I already noticed under the slide column, I know 3 things. I can find 4 or 5. Okay. When they hit the ground, ooh, I think I'm moving on to the ground section. Their legs bend 0.2 meters. I think this is over there. As the child stops, that's a velocity. That's a 0. Is that a V initial or a V final? I think V final on the ground is 0. Okay. All right. What does A want me to find? How fast does the child hit the? Okay, so I'm over on this column. Which V is it asking me to find? I'll give you a hint. I don't think it's asking me to find VF, because what's VF? So what's it asking me to find? Got to be VI. Karen, you see how we put all that together? There's a lot of thinking going on there. Okay. How many pieces of information do I know on the ground side? 2. How many do I need? 3 to find the 4th. For a candy, can anybody spot what I can do here? Donald. Donald, loud and proud. What? How fast you hit the ground, how fast you are at the bottom of the slide must be the same speed as how fast you are at the beginning of when you hit the ground. See what he said? Oh, that gets you a candy. That's good. That's good. Did I promise somebody else a candy about the acceleration that was negative? I'm the king of forgetting to give the candy after the promise. Sorry. So you got the argument? I'm going to realize, first of all, I can't solve on the right-hand side, on the ground side. I only got 2 things. I got 3 things on the slide side. Ooh, and how fast I'm going at the bottom of the slide, V final bottom, must be V initial impact, because that's the transition point. Cool. Okay, so now A said, find V final. I'm looking for an equation that's got a D, a VI, a T, and a VF in it. There is one. Which one? I don't know A. Good thought. I don't know, hey. Having a little deja vu. 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 Sorry, keep joking. So which one? I think it's the one with the brackets. Yeah. Okay. Look at it, look at it, look at it, look at it. See it there? What do I want to get by itself? The VF. Where is the VF? Inside the, do the brackets last. The D is going to drop down like a domino. How will I move the outside the brackets over? I think it's going to be times by 2. Divide by T. And that would leave the VI plus VF by itself. So how will I move the VI over? That's VF. Oh, what was VI as a number exactly? 0? Okay. So it's going to be 2 times 6 divided by 4.8. I think I do that in my head. 2 times 6 is 12 divided by 4.8. That'd be the same as, can I do it in my head, Mr. Dewick? Sure, 120 divided by 48. So divide by 12, 10 divided by 10 over 4, 5 over 2, 2.5? $2.5. And you know what, Donald? Now I'll go equals 2.5. I can fill that in on the ground side. Cool. Nice. Caleb, what's B want me to find? Where? Ground. Oh, how many things do I now have on the ground side? 3. I can find the 4th. So I'll do part B here. A equals question mark. Caleb, I'm looking for an equation that's got a D, a VF, a VI, and an A in it. There is one. Or a VF squared, but yeah, I know what you mean. So can you get the A by itself? Yep. 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 So it's going to be 0 squared minus 2.5 squared all over 2 times 0.2. Oh, does the negative scare me or relax me? When we hit the ground, are we speeding up or slowing down? Come to a stop, slowing down. You know what? The negative relaxes me. I probably did this right. Did y'all get negative 15.6? Good. Don't turn the page yet. I want to notice this equation right here. Okay? How many of you, when you're a little kid, or even in your current age, have jumped off something on the playground and landed on the gravel or on the ground? Okay? And then as you got older, you jumped from a higher and higher and higher height. Okay. When you hit the ground, the bigger the acceleration, the more the jolt. In fact, the more it hurts. So how can you decrease the acceleration when you hit the ground? You bend your, what you're really doing is you're making that number bigger. And when you divide by a bigger number, what happens to your answer? If you're dividing by a bigger number, what happens to the answer? It gets smaller. You figure this out when you're 3 and 4 and 5 and 6 years old, when you're figuring out how the physics of walking and jumping and running works. You clue in, if I land stiff-legged and flat-footed, it hurts. If I bend my knees as I land, what you're really doing is you're increasing D, dramatically reducing the acceleration. Just kind of nerd trivia, but you've kind of figured this little situation out, not the physics of it, but the owiness of it. So kind of cool. Last one, and thank you for your patience. We'll finish, and then we'll take a break, and I can get you some homework to work on. Okay. I think I've told you last day we can also use this in Rcmp car accident investigation. So here's a question. It says this: an Rcmp officer is investigating a car crash. At the scene of the accident, there are skid marks that are 32.5 meters long. The driver of the car was speaking on a cell phone during the accident, and the cell phone has recorded the sound of the skid for 1.2 seconds. The speed limit on the road was 60 kilometers per hour, and the driver claims he was not speeding. Should the driver be charged? Okay, this question's not as clear, so I wrote, what's this question asking us to find? What? VI. So let's write down VI equals question mark. What's that 32.5? What's that 1.2? That's 60. I don't think that's actually part of the question. I think when I find VI, if it's less than 60, not speeding. If it's more than 60, speeding. How many things do I know right now? 2. I need 3 to find the 4th. What else do I know about any car accident ever? So what's VF of any car accident ever? Can I not tell you that? I'm not going to write that in the question. I'll just allow you to assume that. I don't think there's a car accident that's still going on. Yeah. Yeah, I'll deal with that when we get there. For now, which equation? Yeah. I wrote it out. You don't have to if it's on your sheet. What do we want to get by itself? Where is the VI? Inside the? Do that last. What's going to drop down like a domino? The D. Then what? Times by 2, divide by T. And then in my mind, Shay, I see the VI plus VF dropping down. What am I trying to get by itself? How would I get the VI by itself? And, okay. Oh, and by the way, Shay, what is VF as a number exactly? I probably could have just done that. So it's going to be 2 times 32.5 all over 1.2. 2 times 32.5 divided by 1.2. And I get 54.16 repeating. So should this driver be charged with speeding? What are the units for this answer? meters per second. So what do I need to do with this answer if I want to compare it to the speed limit? Convert it to kilometers per hour. Something to do with a 3.6. I can't remember. Are we multiply? Not only is this driver crazy speeding, you could charge them with vehicular manslaughter if they had killed somebody. And this would stand up in a court of law totally. Oh, and by the way, that's the minimum speed. They might have slowed down before skidding, right? Okay. Now, there's a bit of a problem here. Donald, you don't know very much physics yet. And so I had to contrive this question. I had to have the cell phone record the sound of the skid, which is kind of bogus here. But later on this year, I will show you how from only the length of the skid and our knowledge of friction, you can figure out what the initial velocity must have been. And that's what the Rcmp do when they're measuring skid marks and things like that. We just don't quite have enough physics knowledge to handle it. But you could absolutely charge this person. Absolutely. What's your homework? One is good. Number two, I haven't showed you how to do yet. It's tricky. Your hint for number two is you don't have enough information to answer the question, but there's enough information in the question to help you find something in order to find something to answer the question. I haven't done one like that with you. 3 is good. 4 is good. 5 is good. 6 is good. 7 is good. 8 is good. 9 I haven't talked about yet either. See if you can figure it out. Your hint is in number 9, it has 2 trips because the acceleration changes. So in the same way we drew a line down the middle of the page for the slide, I would do a while accelerating and while not accelerating. By the way, if you're not accelerating, what's your acceleration exactly as a number if there's no acceleration? Yeah, A is 0. Okay, so constant speed means A is 0. Cruise control. Ten is good. Yeah, skip 11. 12 is good. Yeah, skip 13. 14 is good. Skip 15. Skiing is fun. So 16 is good. 17 is good. 18 is also, I haven't explained. This is a tricky question. You don't have enough to answer the question. You'll have to find something in order to find something. And I'll talk about these tomorrow afternoon. Okay? 19 is also a very tricky question as well. 19 would be, to me, an example of more of a A+ level or even a Physics 12 level question. I'll see if you can figure it out. And if not, I'll absolutely go over that one in class. And then the challenge question is the same as number 19. I'm not going to assign it, but you can try it if you want to. I've gone on for just a little over an hour, so if you want to take a break, you can. You can start working on the homework, and then we'll pick up with stuff a bit later.